rocket flew, and that's a shame. How did the rocket get to that point? That is what you should really be concerned about. The story of your rocket's flight is just not a peak altitude number. The real story is the trajectory path that your rocket takes during the flight. Does it go straight up or does it arc over? Does it spin as it ascends? What happens once the recovery system is deployed? Where does the rocket go? How far away does it land? Will it touch down in a location where you can easily recover it? These are the answers that you can get using the Launch Visualizer. It is an app on the RockSim.com website, and you can test it out right now for free. Finally, you have a way to simulate your rockets that gives you the true information that you need to be successful. And the best part is that you don't have to walk after your rocket after it comes back down to the ground. Experience the fun. Rockets right now at RockSim.com. Most rocketeers seem satisfied with just being told how high their rocket flew. And that's a shame. How did the rocket get to that point? That is what you should really be concerned about. The story of your rocket's flight is just not a peak altitude number. The real story is the trajectory path that your rocket takes during the flight. Does it go straight up or does it arc over? Does it spin as it ascends? What happens once the recovery system is deployed? Where does the rocket go? How far away does it land? Will it touch down in a location where you can easily recover it? These are the answers that you can get using the Launch Visualizer. It is an app on the RockSim.com website, and you can test it out right now for free. Finally, you have to simulate your rockets that gives you the true information that you need to be successful. And the best part is that you don't have to walk after your rocket down to the ground. Experience the fun. Test your rockets right now at RockSim.com. Most rocketeers seem satisfied with just being told how high their rocket flew, and that's a shame. How did the rocket get to that point? What you should really be concerned about. The story of your rocket's flight is just not an altitude number. The real story is the trajectory path that your rocket takes flight. Does it go straight up or does it arc over? Does it spin as it ascends? What happens once the recovery system is deployed? Where does the rocket go? How far away does it land? Will it touch down in a location where you can easily recover it? These are the answers that you can get using the Launch Visualizer. It is an app on the RockSim.com website, and you can test it out right now for free. And we're live! I've got multiple computers going on today, so I am ready. this works. I hope this works. Yeah, I got a Mac computer here in front of me and a Windows computer over here. And the Windows computer acts like a monitor that I can show what's going on in the Windows computer. Let's hope it all works. So hopefully the sound is coming through. There's people here. Oh, we got Carlos here. How's my microphone, Carlos? Is it coming through okay? This is RockSim Live. My camera out in front of me is upside down. I don't know how that happened. So this is RockSim Live. I am Tim Van Milligan. This is where we talk about RockSim software and the Launch Visualizer and RockSim Pro and Engine Edit, which is another program that comes bundled with RockSim or RockSim Pro. So you get that as well. So if you are new here, thank you for showing up. This is live, but you might be watching it on replay. Today is March the 10th, 2023. This is episode number 111. Next week is Pi Day 3.14, and we're going to celebrate Pi Day with a rocket plan, and this is called the Euler's Revenge. And it's got, Euler was the first person that kind of used the Greek symbol pi to represent, the relationship between the circumference of a circle and the diameter of a circle. And if it wasn't for him, we wouldn't be using pi, although it might be called something else. But so we named this rocket after him, and it's got a whole bunch of Euler's equations on there, and there's ratios in here, including the golden ratio. And this is going to be a plan, and this is going to be available next week, and we'll probably release it a day early, so so that you can talk about Pi Day and have a rocket to show. If you know a teacher, and say, hey, we got this Pi Day rocket over at Apogee, you might want to go check it out. And it's in our newsletter plans. In fact, let me show you where you'll find it. In fact, I've already put the RockSim file up, but the actual, image of the rocket and the fin templates and all that we put in the newsletter, that won't be about until next Monday. But let me go to my computer screen here. So, all right, so this is the RockSim file for it. This is RockSim, and I'm just adjusting my screen size here. Yeah, so this is RockSim, and if I double click here, oh, my computer's running slow because of the extra stuff going on. So, the decal is upside down on this one, but that's easy to change. I can't do anything on that one. It's just running so slow. Yeah, let's not do that. Let me show you on our website. Come on, first I got to get this to, there we go. It's got to reattach itself to the RockSim software, and it's just running so slow. That's because I'm running too much stuff here. But if you go to the Apogee website, so let me open up an Apogee website, do a new one here, and if you go to apogeerockets.com, and this should load here, and if you scroll down on this page, the home page, you'll find the Pi Day rocket, Euler's Revenge. And you can view it in the Launch Visualizer, or you can go to the free plans page and download the RockSim file for it. So if you're on the plans page and you come down all the way down to the very, very bottom, because these are in sequential order when we release them. And down here at the bottom is Euler's Revenge. And this was designed by Martin McKee, who's our product designer here. It's really cool. And he wrote you have to wait until the newsletter comes out, but he wrote a kind of history of Euler and, what he meant to mathematics and pi. So going back to the Apogee website, let me just show you where we are. If you go to the home page, click on that, and that will take you here. And we are doing RockSim Live. And if you want to find our archives, just kind of scroll down on the home page again until you get this picture right here where it says RockSim Training. And you click on that, and that will take you to our archive page. And this lists all the previous episodes and what we talked about, so you can kind of catch up. And if there's a specific topic you want to look at, you can just click on the little timestamp here, and it will take you to the YouTube video. And so you can watch it at your own leisure. Last week, Michelle did RockSim Live. So thank you, Michelle. I really appreciate it. I was in Arizona for a rocket launch, and it was a contest, and I won one event out of like 4 or 5, and it was streamer duration, and I crashed a whole bunch. I crashed so many that they gave me the DQ award. Oh, my microphone just fell down. So yeah, so I had a great time last week at that rocket launch, and thanks to everybody in Arizona, Matt Steele, who ran that contest, and we had Canadians there, we had some Chinese citizens there, so it was an international event. There was about 20 competitors, and I went there because my daughter is competing in the World Space Modeling Championships, and that's on the first week of July in Austin, Texas. And so if you're in Texas that first week of July, and you want to see world-class modelers fly, go ahead and down there and check it out. It's going to be cool. It's going to be a big event. They've been hitting me up for donations. They want air conditioning for the competitors' tent. Okay, so we got some chats coming in here. We got Carlos saying hello. Tony Ermit says hello. Rosa from Ottawa, Canada. And Alex from Milwaukee, Wisconsin. Great, glad to have you. So what I wanted to start out today was, a few weeks ago we got a question about somebody discovered that a motor in the RockSim database, the E30, does not match the NAR website information. So here's Euler's Revenge. I'll just use this as an example. If I go to oh, this is slow. We have Johan says it's snowy in the Netherlands. Oh man, this is running really slow. I got just too much plugged in. What I might do is unplug this monitor here and see what happens. Maybe that will speed it up a little. So I unplugged the monitor, and that unplugged. Did that unplug my mouse? No, that didn't unplug my mouse. It's just thinking. Hopefully I'm still on. Let's see. It shouldn't have disconnected me. As far as I know, I'm live. Okay, it still says it's streaming. Okay, so we'll go on. So we're in RockSim. If I double click here, I can choose an engine. Oh yeah, that did make it faster. If I look at the Aerotech E30 in the database, it says it has a total impulse of 39.512 Newton seconds. And if I go to the NAR website, let's see if I can find the NAR website. Okay, so here's the NAR website. So if you go to nar.org, and then you go to the certified motor list. So what I did was I went to, rocket motor information, certified motors, and it takes you to this page, and when you click on the NAR certified motor list, it opens up this. which lists all the motors. So if I scroll down to the E30, I'll find it again. So here's the Aerotech E30, this line right here. You'll see that the total impulse on this one is 33.6 Newton seconds. So that's a lot less than 39. And people that are in TARC, that's very important to them. So how do you correct this? And this is when new motors are added, it's kind of the same thing. Well, first you have to get the data. And the data is here on the NAR website. So like if I click on the E30 right here, it will open up a PDF. And on this PDF, it shows me the 33.56 Newton seconds. And then it also shows me a thrust curve. And then it gives me, this is when the NAR did their testing, this was their actual test data. And then it gives an engine file published by the NAR. And then if you plot all these points on the graph, you would get this graph. And so this is the actual NAR representative data that gives you 33 Newton seconds. Okay, so now how do you get that information into RockSim? So there's two ways to do it. One, you could copy this information. The NAR puts this information in there, but Tripoli doesn't. And I don't think the Canadian Rocketry Association on their motors that they certified does it either. So I won't do that. But if you could actually take this data and do a copy. So like I'm highlighting it all, doing a copy, Control C on your computer. And then you need to open up a text editor. So I'm going to go open up text editor on the Mac. Text edit. And I'll open, text. Come on, text. And click open. Okay, so that's going to open up a text editor. It's just like, Microsoft Word or whatever. And if I go, it's thinking. Too many things open. I'm going to go new document. Come on, it's still thinking. What happened to it? Okay, there it is. And then if I do a paste, it should paste that in there. Man, it's slow. Okay, so there's that data. And then if I do a file save, and I need to save it as a .txt file. See, the format right now is rich text, and rich text includes the fonts and the size of the fonts. We don't want any of that data. We just want just text, and it's not going to let me. So let me I'll do a file export, or I've got to be able to save it as a .txt. Revert to, share. Let's see, more. I don't think this is going to work because that's sharing in AirDrop or something. Yeah, that didn't do anything. And I opened up in text edit specifically so I could save it as a .txt file. And now it doesn't want to work. I want to put it on my desktop. And I don't want it rich text. Web archive, open document. Well, let's try it that way. It saved it as untitled. Revert to, rename, crap. It's not letting me do it. Okay, well, once you save it as a .txt file on your desktop, then you would go and rename it. If I could bring up a browser here. Come on, this is being so slow. If I got on my desktop, and then here's that file, and then I would just change the name to E30, and it used to be .txt, but then you want to change it to .eng, and then hit return, and it would change it. As you see, it changed it to an engine file. But because this was saved with font information and everything else, it's not going to work. It's got to be text, and just plain text. So anyway, so let me go to the other way of doing this. So what did we have? We had, jeez, where's that? Thrust curve, no, that ain't it. There it is. Okay, so this file right here, or this image right here, we could use, or this image right here. This one's a little bit bigger, so I will use this one. So I need to copy this, and I need to save it as a JPEG. So I'm going to do, on the Mac, I can do a screen grab, and you can do the same thing on Windows. So I'm just going to grab that, and that put it onto my desktop. Okay, so I can close this out. All right, so on the thrustcurve.org website, if I go to the E30, I think they also have the same file that's in RockSim, because we probably got it from their website. So see, this shows 33.6. Let me click on this, and see, this was certification date. It says it's total impulse of 33.6, but when we looked at this last couple weeks ago, it was showing 39. Okay. Anyway, but on the Thrust Curve website, once you have that screen grab of the let me go a bit to this. So this screenshot here of this. Come on, open up. It's being slow. Come on, open. It's this going to be this image over here as soon as it opens up in preview. All right. Once you have this, and if you're creating a new motor, you need this. This is your thrust curve. Yeah, but you need to have it in a format like JPEG. So I'm going to do an export. And I'm going to change it to a JPEG, because right now it's a PNG. See, here's the file format, and I want to change it to JPEG, put it back on my desktop, and I'm going to change the name to E30 image, and it will be JPEG format. Click Save. Okay, so now if I go back to my desktop, there it is right there. That's the file. So on Thrust Curve, I have this tool called Create Motor Files. Okay, you're right here. It's called Thrust Curve Tracer. And there's both a Windows and a Macintosh version. And I know John Coker, who runs this website, he recently updated this application because it wasn't running on Windows or Macintosh. because Macintosh, they have the same problem that we have with RockSim, is every time Apple updates the operating system, it breaks the software. But he's updated it, so it does work, and I've tried it. So I'm going to open up that thrust curve tracer program, and it's in my applications folder. And it's a JavaScript program. Okay, so tctracer.jar is the software. And it's trying to open up right now. So it's like I need another program running on my desktop. So while that's working, let me see if any questions that came in. Wally Ferrer is here from Massachusetts. Kevin's Model is More from Manassas. Oh, he's in Las Vegas back in 1915. Yeah, cool. So you're seeing my live screen. We got 11 concurrent viewers right now. That's really cool. Okay, so did thrust curve tracer open up? Yeah, there it is right here. So this is how you're going to create a thrust curve. All right, so first you need to open the image. And so you click on that button right up there. And it should give us, you know, I need to go to my desktop. Come on. How come I'm not seeing it? It should see it. Downloads. Let's move it from the desktop to a different folder. Maybe we'll see it. Okay, desktop. So here's the image. I'm going to change to make sure it says .jpeg on it. And then I'm just going to drag it into my documents folder. Okay, so now if I go to my documents folder, it doesn't see it. Ah! Let's see if it sees anything. It sees an Altus Metrum. Downloads. It's not seeing certain folders. Oh man, this is weird. User, let's go back up here. Desktop. Nope. It's got to be into my name. Public. I do not know where that public folder is. I swear we should be. Where was that Altus Metrum folder? I'm typing it in. Man, this Windows computer is like really slowing. Okay, so under Tim Van Milligan, Altus Metrum. So let me see if I got another folder open. Let's go back to the desktop. And I'm going to drag that folder. Drag that file. Oop, not that one. Oh, I threw it in my documents folder. So where did my image go? Okay, so there's the image. I'm going to drag it. Okay, so now it's there. Let's see if we can find it now. There it is. I don't know why it's not finding the image. Okay, so that's the image that we downloaded from the NAR website. And let's see if we're seeing the whole thing here. I need to see this program. I can't see it. I guess we can see it. Okay, so the next thing we have to do is set up a grid. You can see it's got a little checkbox that says that we've completed that step. So now we're going to create a grid around this, and first we need to know from 0 to how many seconds, and this is 1.1 seconds. And then we need to know the subdivision so that you count here. So we're going to count 10. Let's try 10. We may have to come back. And then the Y, we're going to go up to 50 newtons. And how many subdivisions? 1, 2, 3, 4. Click OK. And you can see this outline right here. This is our grid. And now you can adjust this grid, and we want to line it up with the axes. So I've lined up that one. And I'm going to take the 0 and line it up here. Take this one and run it out to here. And then take 50 and run it up to here. Okay, so now that grid, I set up the grid, and it looks pretty close. I have this one's just off a little bit, and it might be the PDF that I got from the NAR. Okay, so there's a little checkbox here that says we've completed that step. So then we go to the next step and we draw the points. And now we just click on the graph. And the NAR just makes it simple. I'll just click in each one of these little dots because those are their actual data points. And this will match the NAR data pretty close. But if there wasn't these little dots, you just follow the curve. You can put as many points as you want. I try to do as few as I can because it's just a bigger file. Okay, so now the last point has to be on the bottom line. And if it's not on the bottom line, you won't get a check mark here. Once it's on the bottom line, hopefully you can see this, it recalculates everything. So now it says that my total burn time is 1.2 seconds, 0.02. The average thrust is 34.99, which does not match the NAR website. So we need to tweak things a little bit. So let me see if here's that one here. So the NAR website says 33.56, and burn time is 1.02. Average thrust of 32.95. So if we're back here, so let me make this a little bit smaller so we can see this data under here. So from the NAR website, it says the maximum thrust is 49.3. We're at 49.35. So if I just tweak that point down a little bit, I could probably match it. Oh, this was average thrust. So here's total impulse, 33.89. So I'm pretty close. I'm a little bit high, but not too bad. And their average thrust is 32.95, and this says 34.99. So I want to try to, the big one that I worry about is this one right here, 33.59. This one was 33.6. 33.56, 33.59. Oh, that's just like, I'm going to leave it alone. So that's pretty good. But you can tweak these points around. You can always grab the points and move them around, and it will change these numbers down here. So now we need to add motor information. And so this is where we're going to look at this information here on the NAR website, because we need the propellant mass and all that other good stuff. So we need the name. So the manufacturer's Aerotech. And the designation is an E30. The diameter is, casing dimensions is 24 by 70. And make sure your units are right. 24 by 70. And then the available delays, and I got a 4 or 7. So I'm going to do 4, 7. And the total weight. So mass after firing, propellant mass. Where's total weight? Casing dimensions, certified, date tested, burn time, mass after firing. It doesn't tell me. Well, the mass after firing plus the propellant weight is going to be the initial weight. So we got 17.8 plus 30, 25. So let me bring up a calculator here. So I'm going to take this number, 25, plus this number, propellant mass, 17.8. So 42.8. So that's 42.8. And then the propellant weight was 17.8. 47P. For some reason it doesn't like this. I think it might want dashes. Yeah, it wants dashes there. And then the description, we'll put in our description, RockSim live on 3/10/23, so that we can tell this apart. In fact, I might do make the designation RSL or RockSim live, so that we can tell it apart, because we already have an E30 in our database. The name doesn't really affect anything. Okay, so we've done the motor information. So if I click on that again, it brings it back up. And then we save the data. So here's where we're going to save it. And it's going to save it in an ENG format. Let's see, can I put it on the desktop this time? I don't know. I can always resave it later, right? Let's see if it worked. Yes, it did. I can do it. Okay, so now we have our data file. We've created a new engine file. So we don't need thrust curve tracer anymore, so I can leave that. And at this point, I can either put it into engine edit, or I can put it directly into RockSim. So let me show you how to put it directly into RockSim. So if you're in RockSim, okay, so here's the old database, and it's not in there yet. So I'm going to cancel out of here, and here in RockSim, go to the File menu, and then go Import Engine Files, and it will show a list of engine files. Right now it's looking in this folder called Data Import, but we actually put it on the desktop. So I'm going to open my desktop. There it is, the RockSim E30-RSL.ENG. I'm going to click Open, and it copied it, and then click OK. So it copied it. It just moved it into the correct folder. It didn't load it into RockSim yet. It's just in the correct folder where RockSim wants to see it. All right, so here it is, Aerotech E30.RSL, and then we're going to add it to the selected engine file. So then we click Add, and it moved it out of here and it moved it into here somewhere. There it is, right here. Aerotech E30-RSL. So that's the one that we just created. Click OK. Now if we go to load an engine, click on load engine up here, and we choose the engine. So this is the old one. And so now we should see, let me see if I can find it. Let's go back to manufacturer name. There it is right there. E30-RSL, and look at that. The total impulse is now 33.547. So that worked. I could load it into RockSim. The available ejection delay I should see 4 or 7 as soon as my computer speeds up. There it is, a 7. And we can see the flight events on this rocket. Deploying max ejection delay, starting state, straight up 36 inches, and we'll launch it, just see what happens. So now in our database we have 2 E30s. We have the old one and the new one. So this is the new one, because we gave it a specific name so that we could tell it apart. The name doesn't mean much. You can call motors anything you want, and I would recommend that you give it a unique name, just so that you can find it. So this one went 1,167 feet, and if I load the other one, which should have more total impulse, it should go a little bit higher. So engine code. So here's the old one, 39. Click OK, launch it, and we should expect it to go a little bit higher. Okay, and it did. 1305 versus 1167. So if you're in TARC, I can totally understand why you want, accurate engine files. And I just showed you how to make them. Now, if you wanted to change the name, let me show you how to do that. And I think I'm going to switch to the Windows computer. Let's see if I can do that without losing you. Windows computer. Okay, so I am going to the Windows computer now. Hopefully I don't unplug anything. Let me see if there's any chats that came in. Any questions on that? Terry Wheelock is here. He said, yeah, hello. Okay. Okay, so in Windows, I don't have that file. And I have no way of getting it from the Macintosh to the Windows computer, which is over here. But I'll show you how you can do it on Windows. Okay, so we have RockSim running in the background, but RockSim comes with a program called Engine Edit. And this allows you to modify engine files. Did I open it up? Yeah, there it is. So this is Engine Edit. Okay, it just looks different on this computer as versus the Macintosh. It's a different color. Let me try. We still have a little bit of time, so let me try going to the NAR website and let's see if I can do that copy and paste trick that I just was talking about earlier on the Windows computer. Okay, so rocket motor information, certified motors, certified motors, certified motor list. and scroll down to the E30. There it is. All right. Here is that data. Let's see if I can do a copy. Control C for copy. And then I need an application. What application? Text. Notepad. Let's try Notepad. And then just do a paste. Okay, so that's the file. And then you go File, Save As. Oh, look, see, I can save it as text right here. So let's call it the E30. Why does it want to put it on? Why does this one have an Altus Metrum folder? That's just weird, man. E30. Let's call it E30. I'm going to do the same thing. RockSim live.eng, and it's going to be in text. And we'll do a save. And let's see what happens. All right, so hopefully, so if I go to File, Import, Engine Files, and if I go to my desktop, it doesn't see it. Oh, cool. No engine files. Let me go back to text edit. Let's see if it's what's on the desktop. Desktop. It shows that it's there. And it shows it in the .eng, and it shows it as a text document. So RockSim should see it. So File, Import, Engine Files, Desktop, but it's not seeing it there. Change the name. I don't know if that's going to make any difference. Still not seeing it. Don't know why. I'm going to try and text edit. Try File, Save As. See, it's showing it there. Let's try saving it as .txt. Save. And then go to my desktop. So there's the new file. Let me change the name of this one so we don't have the same problem. I'll call it test. And then this one here, let's rename it .tx or .eng. All right, let's try that. Desktop, still doesn't see it. I don't know. Let's try this. Okay, so we opened Engine Edit. Maybe we can open it in Engine Edit. So let's do a open, and let's go to the desktop. Nope, it doesn't see it. Okay, so the engine files on your Windows computer are stored in this location. So this is kind of a hidden location. So let me show you where that is. So on your computer, if you go to this PC, is it this PC? No, Windows, the C drive, go to Users, and then the name of the computer, and this is the name of this computer that I'm working on. So whatever name that you call your computer. And then inside of that one is a folder called App Data. And kind of look at it, see that it's kind of grayed out just slightly. That's because it's a hidden file. So you need, under the View menu, go to Show, and you want to make sure that the hidden items are selected. So that's turned on, that little checkbox right there. And that will allow you to see called App Data. And then once you're in there, go to Local, then Apogee Components, and then these are, you should only have one or maybe two, depending if you're using RockSim or RockSim Pro. This one, RockSim 1 is regular RockSim. If I go back up a level, like this is RockSim Pro, you can tell them apart. So that will be your difference. You should only have one. I have two because we've been loading multiple things onto here. So then once you're in the RockSim folder, then go to Data, and that's where all your motor data files are. Yeah. So I'm thinking that when this text editor saved this file, it saved it with formatting, because it should have opened just, well, not necessarily. It may be correctly, not correctly formatted. So what we'll do is I want to open up an Aerotech file. So I'm looking for Aerotech. So here's Aerotech. I'm in the wrong thing. I thought I was up here in Engine Edit. So in Engine Edit, open up Aerotech, and it opened up the Aerotech file. And what I want to do, I'm going to find that E30. So now this E30 is the incorrect E30. If I can find it. There it is, E30-T. Shows me total impulse of 39.512. So I know that this one's wrong. So, but I want to save this into its own file. So I'm going to do a split and set up the split files. Okay, so here's the output path. It wants to put it into the same folder. I want to create a new folder. Data engine vendors. No, let's create a new folder. Let's call it test. And then that, and we're going to save it as an ENG. And it's going to save a whole bunch of files here. It's going to save more. It's going to split all these files up into, or all these motor files up into its own separate engine file. I rarely use this feature because I don't know what it did. It just crashed. And it didn't create a new folder. I don't know how to create a new folder on Windows. New folder. Let's call it test. What happened to my engine edit? Am I confusing you? I'm confusing myself. This is how I learn. It's just playing around. It's been such a long time since I do this. Open. So there's our new folder. I just want it, that bolt. I want that E30. And I want to do file. and I have to split them up. Append is how you bring them together. So if there's a new E30, you could bring it in, and that's what I wanted to do. But here I would have to split it up first. And what I wanted to do was to look at the data. I wanted to look at the format, see if my format was wrong. Test, output file, ENG, output file prefix. I don't care what it is. Include an engine manufacturer in the name. That's fine. I want it to be not RSE, I want it to be .eng. And click. And this is where it crashed the last time. Cool. It crashed again. Let's try. Instead of doing Aerotech, let's do Apogee, because Apogee doesn't have very many motors. There's only 3 motors in here. File. Save as. I wonder if file. Let's do save as in the test folder. Apogee.eng. I just want to look at it's going to give you a warning, and I think it did it this time. Okay, so let's see what happens. Let's open it in Notepad. And just once. Okay, so here's the 2 files. There's the one that we got from the NAR. This is the one from Apogee. You see the formatting right here? There's a space right there. In this one, there is no spaces, and I think that might be the reason why it didn't see it or won't acknowledge it. So you'd have to take out all these spaces right here. And there was also a semicolon between the 2. The formatting on the ENG format is very precise, and it's easy to get it screwed up. This is why you have to kind of have 2 files open so you can compare them. And you can see the more data points there are, the more work you have to do, and that's why I try to use as few data points as possible, just in case you have to do this. Imagine a motor where you had 1,000 data points on your thrust curve. Okay, so now I want to look at this line right here, because this is also important. So on the Apogee one, okay, so these are the delays right here. So there's a dash between the delays. Okay, so there's a dash between the delays, so that's okay. And this must be the propellant mass, and this must be the total mass. Yeah, so this was propellant mass and total mass, and this was the name of the vendor, Aerotech. I'm just trying to compare. Oops, look. Okay, so this is a new file. Remember that file from Apogee had 3 motors in it. This one only has 1 motor in it. And is there anything at the very end? Yes, you need a semicolon at the very end of your motor data. All these characters, when you're messing with engine data files, are very, very important. Okay, so file, save, and hopefully it saved it. And let's go back to RockSim. Where's RockSim? RockSim. There's RockSim. File, import, engine files, desktop. Still doesn't see it. I don't know why it doesn't see it. So we're in Engine Edit. Let's see if Engine Edit will see it. I kind of doubt it. Open, desktop, still doesn't see it. Why is it not seeing it? I don't know. Oh, it's a frustrating day. I thought it was going to be cool. It was going to be so cool, but then I can't get it to see the file. Let me see if there's any questions that came in. Alfred Indy says, setting an altitude on the RockSim launch visualizer of 400 feet Jolly Logic 3 parachute release. I am trying to run a sim on my level 1 attempt. So he is asking, how do you set up a Jolly Logic in RockSim? Okay, that I can answer. So let me, I'm going to disconnect this computer right here because I think it's causing me problems. Maybe it's slowing things down or something. Okay, so let's go to my desktop. Let's go back to RockSim. Okay, so this rocket right here is, I think it's a BT-60, so a chute release should fit into it. So we're going to set it up as dual deployment. To do dual deployment or chute release, and this is the confusing part that everyone can't wrap their minds around, because in a chute release we have to trick RockSim. And that's the thing we're going to do. We're going to trick RockSim to say that it's like a dual deployment rocket. But in a chute release, we don't have two parachutes. We only have one parachute, and it's bundled tight by the chute release. And then it releases it at a certain altitude. But in RockSim, we have to trick it, acting it like it is a dual deployment rocket. And in a dual deployment rocket, you have two recovery devices. So you must put in a second recovery device in your rocket. So if you click on the rocket components, this rocket shows just one parachute inside the rocket. Let me see if I'm trying to speed up this computer here. I'm going to take that one and delete it. And maybe that will speed it up. We need a second parachute, even though it's not really there. But we need to have a recovery device. You know what? It's going to be like this. The rocket's going to be coming down, flopping around, and we're going to use a small parachute or a streamer to simulate this condition where the rocket's falling like this. It's not coming in ballistic, it's falling like this, it's tumbling. And so we're going to use something that will fall fast. And that's why we can either use a streamer or a very small parachute, just to simulate the rocket falling with the parachute bundled up. So what we're going to do is in the body tube, I didn't speed it up. We're going to put in a streamer. It's so slow. This computer does not like running all this software at the same time. And it's a pretty fast computer. So I'm going to put in a small parachute. I'm going to put in a 2-inch wide streamer. And as soon as my spinny ball stops, I'll click OK. I don't care where the streamer is. As long as it's in the rocket, you'll be fine. Come on, spinny ball, stop spinning. Oh, this is so slow. Okay, so now I put the streamer right there. So now we're going to go prepare for launch. What can I do to speed this thing up? Let's close some windows. Close that window. We got RockSim. Okay, so we got an E30-7 loaded. So now we have 2 devices. So the streamer is going to be deployed right at engine ejection. So we're going to set that at engine ejection, and then the parachute we're going to deploy at an altitude. So basically we're just setting a chute release up just like a dual deployment rocket. So, and then we're going to, not Apogee, altitude, and we're going to set it at an altitude, I don't know, 400 feet. So even though this, in real life, this streamer's not there, but in RockSim, we have to put it in there because we're tricking RockSim to take the rocket and break it apart and fall and tumble and wiggle around as it comes down, just like it would under the chute release. And then we can do the flight profile and see what this looks like and see what happens. And let me quit this. I'm going to quit all this stuff while this is doing things. Can't quit that, but I can quit that. Okay, so now I got a lot fewer programs running. Okay, so here's the rocket, and we launch it. The rocket takes off. It goes up to its peak altitude. At this point, we'll see a streamer pop out, and it's falling fast, just like it would in real life. We're just simulating what's going on in real life. And then when we get down to 400 feet, so at 400 feet, we'll see the parachute pop out, and there it is. Parachute pops out, and you know the chute release worked, and now the rocket comes down. So that is the trick on doing a chute release in a rocket. The hard part that people don't wrap their mind around is that we're tricking RockSim to break the rocket apart. And how do we break it apart? Well, we can only do it one way, and that's dual deployment. So we're going to break it apart, have a streamer come out so it falls down fast, and then at the right altitude, the chute release releases the parachute, and then it comes down nice and slow. So that is how you do a Jolly Logic chute release in RockSim. And I'm just scrolling through this. We didn't get a lot of questions because I was screwing around in Engine Edit and not getting it to work. I'm gonna have to play around on the Windows computer and figure out why it won't see my desktop. Okay, so we have gone our allotted time. And if my computer was faster, I'd probably stick around a little bit. Terry Wheelock says, how do we make a blunt, flat, conical nose cone? He's probably thinking like a Cran rocket, or maybe like a Gemini capsule. And that's a really good question, but we're out of time, so we'll try to answer that one next week. That's a really good question. So we will be back the same time Hopefully I got my computer that runs faster. So that will be March 17th at 2 p.m. Mountain Time Zone. We'll actually be on daylight savings time next week. So we're gonna, so you people that are in Johan, in I don't know if when you guys switch over to daylight savings time, but we switch over on Sunday night. So it will probably be an hour earlier for you. But for everybody in the United States, except for those people in Arizona who don't switch, so in Arizona, we'll also be an hour earlier. Okay, so until next week, in 5, 4, 3, 2, 1, go out and launch something.